Last class we talked about arithmetic sequences, which, recall, an arithmetic sequence is just a series of, I shouldn't say series, is an ordered list of numbers separated by the common difference, the same number added or subtracted. What we're looking at today is an arithmetic series. What should you equate a series with? Nope. No, it's not. Nope. 2 times ago. What should you equate? What? A series is a sum. You please know this. A sequence is a list of numbers. A series is a sum. So where last time we may have found, the 20th term, what we'll be looking at today is finding the sum of the first 20 terms. Okay? So, our main goal is to be able to evaluate an arithmetic series. And we'll do that a couple of different ways. An arithmetic series, again, this is a sum. It's really important for you guys to understand the difference between a sequence and a series. This is a sum of an indicated number of terms in an arithmetic sequence. This is denoted by a capital S sub n. Okay. So when we say this is denoted by capital S n, what that means is, for example, S sub 100 would mean you are adding up the first 100 terms of a sequence. Okay? Okay. There is a formula for this. Lucky you. You don't actually have to list out and add up 100 numbers. Okay. There is a formula. S sub n equals n times t sub 1 plus t sub n all over 2. And we'll talk about what all these different parts mean. I'll give you a second to jot that down. So the n is the number of terms that you are finding the sum of. Like we said, if you're finding S of 100, that means you're taking the sum of the first 100 terms. T sub 1, we should know what that means.
First term.
Okay, good. That's our first term. And then T sub n, what does that mean? Carly, what does T sub n mean?
Like, if you're solving for example, the sum of 100, that term of 100 in that problem.
Very good. So what I like to think of T sub n as is kind of like the last term in those lists of numbers you're finding the sum of. So like the example Carly gave, if you're finding S sub 100, then that T sub n in that case would be T sub 100, the 100th term. Okay, so kind of like the last term is what I equate that to.
So when you add that together, do you do the first term plus 100?
No. This was just a specific example. It's the last term in whatever you're finding the sum of.
Okay.
So if it's S sub 80, then that T sub n would be the 80th term.
Okay.
It's like the last one in what you're adding up.
So do you have to find that?
Sometimes we have to find that, exactly. Okay. So if you look at the first example, yes, I know you can add in your head 2 plus 4 plus 6 plus 8 plus 10, but I want you to see how that formula works, okay? So, start with the formula. This is another thing that you would be given, but you have to know how to use it. So off to the side, let's kind of write out what we know. What's the value of n? No. No. Why 5? Because there are 5 terms. You're finding the sum of 5 terms. Exactly.
I could have sworn someone just was last one.
That's T sub n. What is T sub 1? Okay, that's the first term. What is T sub n? That's 10. That's the last term. Your value of n and your value of T sub n are two completely different things. So now let's plug in what we know. So we're finding the sum of 5 terms. Our value of n is 5 because we're adding up 5 terms times 2 plus 10 all over 2. And then it's just a matter of doing a little calculating in your calculator. This one we could probably do in our head, though. Two plus 10 is 12, divided by 2 is 6, times 5 is 30. Look at the next example. Same type of thing. Let's start. Yes, I know you can add those up, but we want to see how the formula works, how the different parts work before we get into some more complicated problems, which you're going to have. All right. What is the value of n?
4.
Why?
Because there's 4 terms.
Okay, because we're finding the sum of 4 terms. What's T sub 1?
5.
Claire, what is T sub n?
29.
Why?
It's the last term.
Okay, there we go.
I was at 4.
So S sub 4 is equal to 4 times 5 plus 29 over 2. And then just simplify. If you have everything you need, using this formula is like a 3rd grader could probably do it.
I could not have done this in 3rd grade.
Yes, you could have.
Oh, no.
I didn't know what variables were in 3rd grade.
Look at the next example. It says, for each arithmetic series, find S sub 11, which means I'm adding up how many terms?
11.
Okay, that means I'm adding up 11 terms. So think about this formula again. I need the first term, I need the last term, and I need the value of n. Well, we have the value of n, that's just 11. So let's go ahead and plug that in. What else do I know?
1.
I know the first term is 16.
Couldn't you like
What I don't know, however, is the last term. So, hey, Alyssa. I get when you're only going up to 11 terms, it's not that big of a deal to just, what would you do? Subtract 4, subtract 4, subtract 4. But I want you to always keep in mind, if that were S of 1,000, you're not going to want to do that. So we need to think of a different method. Okay? So here is where we go back to what we did last time. Here is where we go back to what we did last time. I am looking for what term?
11.
I am looking for the 11th term. So I can use that explicit formula for our sequence to find the term I need, and then we can plug it back in. The first term again is 16. The value of n was 11. What's the common difference? What is it? Negative 4. Negative 4. So once you have found that 11th term, then you can plug it back into your series formula to finish that up. We are still trying to find the 11th term. I'm sorry, we're trying to find the sum of the first 11 terms, but we need the 11th term. So let's fill in what we know to the series. S sub 11 equals 11 times, this time our first term is negative 16. I need to find that last term. Yeah. What's our common difference on this case? Oops. Missing a plus. So let's jump over to this theater example. You're going to have a lot of word problems and a lot of application problems where it's up to you to decide whether you're looking for a term or the sum, a lot of different things. So let's look at one. It says the number of seats in the first 14 rows of the center orchestra aisle of the Marquis Theater in Broadway form an arithmetic sequence as shown. So what we probably ought to do is count how many seats are in row 1, 2, 3, and 4 to see what's happening in this sequence. So with that being said, how many seats are in the first row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can somebody count up row 2 for me? What about row 3?
Probably 13.
It's probably 13. And it's probably 14. Yes, it is. So right away, before you even start doing any problems, here's what I do. I list out everything I know. I list out what's my first term in this sequence. 11. I list out what's the common difference. 1. I just list what I know because chances are I'm going to need that information at some point.
Would T sub n be the
Exactly. So T sub n would be T sub 14. We don't know that quite yet. If you look at the first example, that's what we're starting off to find. But you're right, T sub n would be T sub 14. Which means the value of n is what? 14. So just listing what we know from what we're given, then we can, as we need to, use that information. So the first question is, how many seats are in the 14th row? Are we looking for a term or are we looking for a sum? A term. Okay, good. So am I using the sum formula or am I using the term formula?
Term.
Okay. I'm looking for the 14th term, like Claire said, that's T sub 14. My first term is 11, my value of n is 14, and you said our common difference was 1. How many seats? 24.
I just got 245.
Question. Now, how many seats in total are in the first 14 rows? Is that looking for a term or a sum? So let's use the sum formula. Again, our value of n is 14. I'm looking for the sum of everything in the 14 rows. So n is 14. The first term, again, we said was 11. We have just found T sub 14. That's 24 all over 2. Then it's just a matter of calculating in your calculator.
I think that one might be.
That one is 245. Sheila begins an exercise routine for 20 minutes a day. Each week, she plans to add 5 minutes per day to the length of her routine. For how many minutes will she exercise each day of the 6th week? Am I looking for a term or a sum? Carly, I'm sorry.
Well, it's a term, but I was confused on that. Each week she plans to add 5 minutes per day. Does that mean she adds like 5 minutes each week?
That's a good question. It means, so the first week she's exercising 20 minutes every single day. The second week she's exercising 25 minutes every day. So yeah.
So much if we were
5 days a week or 7 days a week?
Let's say
7.
7.
Okay, 35. She adds 35 each.
No. She adds 5 minutes
And does that for a week.
and does that for a week.
And then the next week she'll
25 the next week.
Yeah. Okay. So am I looking for a term or am I looking for a sum for this? How many minutes will she exercise each day of the 6th week? Term.
Oh, yeah.
So T sub 6 is what we're looking for. The first term is the 20. That's what she's exercising. Yeah, no, I get how that wording is weird. I get it.
But we have weird wording on the chart.
Just relax. Our value of n is 6. What's the common difference?
5.
5, okay.
Did we say 7 days a week or not 5 days?
It really doesn't matter if it's 5 or 7.
Wait, you said 7 though.
Then 7. It doesn't matter. It doesn't matter. So, during week 6, how many minutes is she exercising?
45.
45 minutes per day, whether it's 5 days or 7 days, it doesn't matter. All right. What happens to the length of Sheila's exercise routine if she continues this pattern for 2 years?
Oh my god.
She would probably die, but...
That's like 730.
No, we're actually, we're finding the term. So in 2 years, how many weeks is that? 104. 104, okay. So 2 years is 104 weeks. So we're looking for T sub 104. How many minutes is that? 535 minutes. If you think about how many minutes are in a day? That's almost 9 hours. Yeah, she'd probably die.